Hello, receiving students, teachers, and 6C. Thank you. You may take your seats. In our last lesson, we looked at measuring the amount of force, and we used different instruments to measure the force of different objects. And I also gave you a homework to do, receiving students, and 6C, receiving teacher, you can check with your students. Our question was, change 39.5 kg to Newton. That was our homework. Change 39.5 kg to Newton. Receiving teachers, you can check with your students. Let's hear from the model class. Anna Morrow, thank you. $395 newtons. Very good. Okay, that's the correct answer. Anna Morrow, can you come to the front and do the working out? Please, thank you. .95. 5. No, kg. Kg times, no 5 kg times what? Times, multiply, times, x. Equals 95 newtons. Okay, thank you, Anna Morrow, for your working out. Let's look at the working out. Receiving students and 6C. Okay, we have 3.95 times 10 is equal to 395 Newton. Is that answer correct? Receiving students and 6C. Yes or no? 395 newtons. Is the answer correct? Receiving students? All right. The answer is correct, 395 newtons. Now, when we looked at our summary in the last lesson, it says that if the scale is in kilograms, you multiply by 10 to get Newton. That was our summary for the last lesson. So here we have 3.95 kilograms, okay? So we multiply by 10 to give us 395 Newton. Are we clear? Okay, very good. Now let's look at our answer on the screen. Okay, so there, number one, working out 3.95 times 10 will give you 395 Newton. The next working out, the second working out, you can multiply 3.95 times 1,000. Okay? 1,000. How many grams is equal to 1 kilogram? How many grams is equal to 1 kilogram? How many grams is equal to 1 kilogram? Receiving students and 6C. Fred, thank you.
$1,000 kilogram.
How many
1,000 grams.
1,000 grams is equal to 1 kg. So that's why for us to change kilograms to grams, we multiply 3.95, times 1,000 will give us 39.5 times 1,000 will give us 39,500. 39,500. So you divide that 39,500 over 100 will give you 395. Okay? Because in our last lesson, the second summary point says that if the scale is in grams, you divide that by 100 to get Newton. So that's what we are doing. 39,500 divided by 100 will give you 395 Newton. Are we clear, receiving students and 6C? Thank you. Okay, let's move on. Receiving teachers and students and 6C, we are still looking at the same outcome, strand and substrand. Okay, receiving students and 6C, I have 2 toy cars on the table. I want you to look at the toy cars very carefully and closely, okay? And I'll ask you some questions. What is wrong with these toys? What is wrong with these toys? Receiving students, you can tell your teacher. 6C. What is wrong with these toys? C. What is wrong with these toys? Fred, thank you.
The rim is missing.
The rim
Is missing.
missing. Good try. Okay, Can it move by itself? No. Okay? So there's something wrong with this toy. It cannot move. Can it work? No. Okay, it cannot work. So there's something wrong with this toy. Now, why don't they work? Why don't these toys work? Receiving students and 60. Melisha, thank you.
Force is not applied.
Force is not applied. Very good. What else? Receiving students, you can tell the teacher. Why don't they work? Or why can't they move? Come on, 60 and receiving students. Minol, thank you.
Because it is a toy and it cannot move by itself.
Because?
It is a toy and it cannot move by itself.
Very good. Thank you, Minol, for that answer. Because it is a toy and it cannot move by itself. Okay? Very good, Minol. Now, I will ask Nora to come to the front. Thank you, Nora. Come to the front and you will demonstrate how this toy can move. Can you demonstrate to us how this toy can move? Okay, very good. What is she doing? Receiving students and 60. What is she doing? What is she doing? Elipoli, thank you.
Applying force.
Applying force. Very good. What type of force is she applying? Elipoli, again, thank you.
Push.
Push. Very good. Receiving students, I hope you have given that answer also. Thank you, Nora. Let's give her 3 big claps. Thank you very much. Okay, now that brings us to our topic, model planning number 1, lesson number 1. Okay, before we do our main activity, let's look at the safety note. Okay, our safety note, receiving students and 60, handle the toys carefully, especially those ones that require bouncing, tossing, or betting to avoid injury. So that's our safety note for today's lesson. Our instruction, are we following receiving students and 60? Okay, our instruction, place the toys on the table where all the students can see the objects and answer the following questions. So, receiving students and 60, you should have the toys placed on your tables. Okay? So these are the questions that you will answer. Question number one. Question number one. What did you have to do to get these toys moved? That's question number one. Question number two. What do you think happens to objects when you increase the amount of force that is applied to them? What do you think happens to objects when you increase the amount of force that is applied to them? And question number three, what would happen if you tried to push a real car with just your finger? What would happen? So these are the three questions that you will answer, receiving students and 6C. Like I've said, you should have the objects or the toys placed on the table. And when you go through question 1, 2, and 3, you try to do some demonstration, okay, with the toys that you have. Okay, you can start now. I will give you 5 minutes. I'll give you 5 minutes to answer those three questions, receiving students and 6C. While you are answering the questions, someone can demonstrate. Demonstrate with the toys that you have. All right, for question number 2, what do you think happens to objects when you increase the amount of force that is applied to them? Now, in that case, you can push or tap the toys that you have hard, okay? Push the toys hard. And you see how fast it can go. That's for question number 2. Okay, you try and push the toy harder, a bit harder. Like this. Let me see. Okay. But you try. Okay, so you can also pull out, pull. You can push and also you can pull, drag, pull back, and then you let it go. All right, okay, receiving students, and 6C, we will go through the answers for the 3 questions. Okay, question number 1, let's look at question number 1. Receiving students and 6C, what did you have to do to get these toys moving? May I have some answers from the model class? Helen, thank you.
By pushing it.
Okay, by pushing it. What else? Ashanti?
By applying push force.
By applying push force. Okay, it's the same as number 1. Okay, thank you. Anna Moro, thank you.
By pulling it.
Very good, by pulling it. Okay, so we have two answers, by pushing it and by pulling it. Very good. So every time when we push or pull something, we are applying force. Remember that, receiving students and 6E. Okay, let's move on. Question number 2. What do you think happens to objects when you increase the amount of force that is applied to them? What do you think happens? Receiving students, you can give your answers to your teachers. 6E? What do you think happens to objects when you increase the amount of force? Force is referring to pull or push. So when you increase the amount of push or pull, what happens? For example, when you push a toy a bit harder, what happens to the toy? It moves fast or faster, okay? So when you increase the amount of force that is applied on the toy will move faster and further, okay? Are we clear, receiving students and 6E? Okay, very good. So that's for question number 2. Question number 3, let's move on, receiving students in 6C. What would happen if you tried to push a real car with just your finger? What would happen? Madhu, thank you.
It won't move.
It won't move. Very good. Why do we say that the car will not move when you try to push that car with just your finger? Lorraine, thank you.
There's not enough force applied.
Because there's not enough force applied. Okay, very good. Any more? Receiving students and 6C? Okay, the reason has been that there is not enough force applied. Okay? Very good. Now let's look at our homework. Okay? Our homework for today's lesson, receiving students and 60, you will write the meaning of the following words. Okay? The 3 words that you see on the screen, we will look at these words in our next lesson. So it is very important that you know the meaning of these words, receiving students and 60. I will give you 2 minutes to copy down the homework into your exercise books. Our summary for today's lesson, we have 2 summary points. To move an object, a force, that is a push or a pull, must be applied. And bullet point number 2, the stronger the force, the further and faster an object will move. Our key phrase for today's lesson, receiving students and 60, applying force. And our next lesson topic will be on model planning. That will be lesson number 2. And the materials that you will need, receiving teachers, students and 60, A3 papers, pencils, color pencils, crayons, rulers and markers. Those are the materials that you will need for the next lesson. With that, thank you, receiving students, teachers, and 60 for your participation, and you have a nice day with your teacher.